Okay, welcome back to the third video of section 7.4, and it is the partial integration of rational functions by partial fractions. A very quick 30 seconds reminder of rational functions. If we zoom in here, we will see that rational function consists of numerator and denominator, and what you will find in the numerator is a polynomial, and what you will find in the denominator is a polynomial, one of those examples up here. Okay, so it's a polynomial over polynomial, and that's what we call it rational function. And then what we need to do is integration of those function, and that integration we will do it using the partial fractions. And to remind you of partial fractions, the main ingredient is to factor the denominator into two parts, and then we separate them, like we split them. We split this part and this part. So this will be integral of 1 plus 2x, 3 minus x, and then there is a constant here and a constant there, which will make it an easier example. Please refer back to our videos from last time to see how we solve question 1 and 2. Let me remind you of the step of the partial fraction decomposition. We said there is a step 0. Sometimes we need it, sometimes we don't need it. It depends on the degree. If the degree of the numerator is the same or larger than the degree of the denominator, then we need to do something which we call it long division. It's something you have seen before. We will just remind you of it at the end of this video. Step number 1 is how we need to factor the denominator completely. As much as we can, everything should be completely factored. And then we need to write the partial fraction. Then there are constant. We will find them in the partial fraction. We need to find them. And the final step, we do the integration. And usually the integration is the easy part, because as you have seen before in video number 1 and video number 2, what we will get from partial fraction is something is easy to find the integral. I will not go through the examples that we did last time. We did 3 examples. Let me do question number 4. Question number 4 is we need to write the partial fraction decomposition of the function. And he insists here that we don't need to find A, B, C. We know how to find them. That's good, but we don't need to find them. So just let us don't evaluate the constants. That's a typical question. Yeah, let me also remove the integral. I will explain how we do the integration, but for now let's not focus on how we do the integration. Let's focus on how we find the partial fraction. Okay, step number 1, we need to check what is the degree of the numerator. Degree of the numerator is equal to 1. What is the degree of the denominator? Degree of the denominator equal to 3. So we are in the good scenario because the degree of the denominator is the largest. So we don't need to do long division. We don't need to do step number 0. We don't just need to write the factorization. So if we factor this one, this is x, and this will be x squared plus 1. Just take x as a common factor. Now you ask yourself, can we factor this one? Yes or no? Well, it depends. First of all, this is quadratic. This is quadratic. And it consists of the form ax squared plus bx plus c. In this example, a is 1, b is 0, and c is 1. So I want you to use mod 5-3 in your calculator. Try to find the roots of this one. What you will get I, the complex number. If you get this one, we conclude that this is irreducible, which means we cannot factor it anymore, quadratic. I think this is mostly the standard way we can explain it, and this is how we will do it. Please try it at home, check, do you get a complex number? Then you cannot factor it anymore. And then the 3x minus 8 will be there. Now the next step is we need to split, because partial fraction just take care of 2 things. We split over x plus we split over the other factor, x squared plus 1. Now Remember, this is quadratic and this is degree 1, so it is linear. Degree 1. If we have a linear degree 1, all what we need to write in the top is a constant a. If we have a quadratic, we have to write px plus c. This is the only two cases. Either we get degree 1 and we write a, or we get irreducible quadratic, which means that thing that we cannot factor, and then we write px plus c. Okay, that's how we solve the first question, because all what we need to do is writing the partial fraction without finding the constant. Now, let's go back. How do we do the integration? Well, I think this is easy. This will give you ln x. Now, here I need to split up this one and use u substitution, u equal x squared plus 1. And this one, it's very easy. It will be the tan inverse. Or, if you want, you can use the substitution, x equal tan theta. So the three integral are fine and easy to be done. Let's go to the next one, and let's think about the next one very carefully because it's a very long question. First of all, can you tell me what is the degree of the numerator? Yes, it is 3. Now, can you tell me what's the degree of the denominator? Well, we can need to count. This has degree 3. This has degree 1. If you add them, you get 4, because remember, I will multiply x cubed by x, I will get x4, and that's the maximum thing I can get. Now, are we in a good scenario, good situation? The answer is yes. And why is that? Because the degree of the numerator is less than the degree of the denominator, so we are totally fine. The next step, we need to factor. Look at x plus 5. Can we factor x plus 5? Can we factor this one? No, we cannot factor it. How about this one? Can we factor it? Yes, we can factor. So we get x squared minus 3x plus 2. And here we have 8x cubed minus 8. Remember, we don't need to factor the numerator. This can be factored, but we don't factor it. We just factor the denominator. Now, I'm asking myself, can I factor this one? Well, mod 5(3) using the calculator, that's the best idea. At least it will give you an idea if you can factor it. A is 1, B is -3, C is 2. If you do it in your calculator, mod 5(3), you will get x1 equal to 2, x2 equal to 1, I believe. And so, how do we factor it if we get x1 and x2? I think the idea is very easy. You just need to go there and do the factorization, which is x plus 5, 8x cubed minus 8. And this will be x minus, and here you need to write x2, and here you need to write x1. So this is x1, this is x2. Now the final step is, if you can see, all the factors are linear, all of them of degree 1, so we just need to split. So x minus 2, x minus 1, x plus 5, and at the top, because each one of them is linear, what you need to write in the top is a, b, c, d. And that's how we do this example. What we will do next is we will do a question which requires us to do long division. So I'll stop this video now, and the last video will be the last question in section 7.4, which about doing the long division first, and then you need to do the partial fraction. Thank you.